Hello students, welcome to the St. Angel's online classes. We are working from home. So today we will look at the question number 5 of exercise 4.1. So you have given that verify through the method of principle of mathematical induction and 1 is to 1 into 3 plus 2 into 3 square plus 3 into 3 cube up to n into 3n equals to 2n minus 1 3 raised to n plus 1 plus 3 upon 4. So what was the first step? That we will see that whether this expression is true n is equal to 1 or not. So we will see whether Pn is true for n equals to 1. So P1, it means what? 1 is to 3 equals to 2 into 1 minus 1, 3 into 1 plus 1 plus 3 upon 4. So it will becomes what? 2 minus 1 1, so it becomes 3 square is 9, 9 plus 3 upon 4, it means 12 upon 4, it means 3. So 3 equals to 3, which is true. Okay students, now we will assume that this statement is true for n equals to k. Assume Pn is true for n equals to k. Okay, so now Pk such that 1 is to 3 plus 2 is to 3 square up to k is to 3 raised to k equals to 2k minus 1, 3 raised to k plus 1 plus 3 upon 4. That it is true, we have assumed that. Now we will consider it as equation number first. Now if we could say that this statement is also true for k plus 1, then our question will be finished. Okay, so now we will show that Pn is true for n equals to k plus 1. Okay, so it means P k plus 1 equals to 1 is to 3 plus 2 is to 3 square up to k into 3k plus k plus 1 into 3 raised to k plus 1 equals to 2k plus 1 minus 1, 3 raised to k plus 1 plus 1, it means k plus 2 plus 3 upon 4. So this statement we need to prove. Okay. So for this I am taking LHS. So 1 upon 3 plus 2 upon 3 till here y equation first. This expression will equals to 2k minus 1, 3k plus 1 plus 3 upon 4. So I am writing it directly because we have already done 4 to 5 questions like that. So we can skip that step. Okay. So it will becomes 2k minus 1, 3 raised to k plus 1 plus 3 upon 4 plus k plus 1 dot 3 raised to k plus 1. Y equation first. Okay. So now here I am taking 4 as my LCM. So it will become 2k minus 1, 3k plus 1 plus 3 plus it will becomes 4k plus 1, 3k plus 1 upon 4. Students, please note it down and pause the video. Now we will take 3 raised to k plus 1 common because since we have in this term and in this term. So from these two terms we are taking 3 raised to k plus 1 as a common. So it will becomes 3k plus 1 as common. Now I will left with 2k minus 1 over here and 4k plus 4 over here. 4k plus 4, okay, plus 3 upon 4. This 3. So when we will solve it, it will becomes 3 raised to k plus 1, 2 and 4 6k and 4 minus 1 3 plus 3 upon 4. So from here I am taking 3 as a common. So 3k plus 1 into 3 inside it will becomes 2k plus 1 plus 3 upon 4. Now it will become 3k plus 1, 3 is into, so one power will add up. Okay, now inside this I am adding 1 and subtracting minus, so this 1 plus 1 becomes 2. So 2k plus 2 minus 1 plus 3 upon 4. Why I have done it? Because in the LHS side I am getting 2k plus 1 minus 1. So if I'll add 1 and subtract 1, so here I can take 2 as common, then this expression will be same like this. Okay, so that's why I have added 1 and subtracted. So from here it will become 3k plus 2 and take 2 as a common from here. So it will becomes 2k plus 1 minus 1 plus 3 upon 4, which is equals to my RHS. Since pk plus 1 is true whenever pk is true, hence by principle of mathematical induction my Pn is verified for all n belongs to positive integer. Student, please pause the video and note it down. Now look at the question number 10. I left question number 7, 8, 9 for you because they are similar. You can easily solve them. Okay. So question number 10 is Pn 1 upon 2 into 5 plus 1 upon 5 into 8 plus 1 upon 8 into 11. This equals to this we have to prove. So first we will prove Pn is true for n equals to 1. It means P1 such that 1 upon 2 into 5 into 1 upon 10 equals to 1 upon 6 into 1 plus 4. It means what? 1 upon 6 plus 4, 10, which is true. Now assume Pn is true for n equals to k. For n equals to k, it means pk equals to 1 upon 2.5 plus 1 upon 5 into 8 plus up to 1 upon 3k minus 1, 3k plus 2 equals to k upon 6k plus 4. It is true and we will consider it as first. Now we have to show that this expression is also true for n equals to k plus 1. So now we have to show p k plus 1 equals to 1 upon 2 into 5 plus 1 upon 5 into 8 plus 1 upon 3k minus 1, 3k plus 2 plus 1 upon 3k plus 2 into 3k plus 5 equals to k plus 1 upon 6 k plus 1 plus 4. Now this we have to prove. If we are able to prove this one, then our question will be finished. Okay, so now I am taking LHS. So from the equation of first, the expression from here till here. What is the value of this expression is k upon 6k plus 4. So I can write directly that k upon 6k upon 6k plus 4 plus 1 upon 3k plus 2 and 3k plus 5. Okay, now from here I am taking 2 as common, so I left with 3k plus 2 plus 1 upon 3k plus 2 and 3k plus 5. Okay, so from here I am taking 1 upon 3k plus 2 as a common, and what I left with, that would be k upon 2 plus 1 upon 3k plus 5. Okay, so from here I will take 2, 3k plus 5 as LCM. So it will become 1 upon 3k plus 2. So the LCM would be 3k plus 5 into 2. So here it becomes 3k square plus 5k plus 2. Okay students, so now 1 upon 3k plus 2, it will, we can easily do the factorization over here. So it will become 3k square plus 3k plus 2k plus 2 upon 2 3k plus 5. Okay, so now here 1 upon 3k plus 2. Okay students, so now from here I am taking 3k as common, so I will left with k plus 3. From here I am taking 2 as common, I will left with k plus 1. Do one thing, first of all note it down till here, then we'll solve it further. Note it down. I am doing here because there was lack of spaces. So from here, now take 3k as common. So 3k, and what I left with is k plus 1. And from here, I will take 2 as common. So I will left with k plus 1 upon 2 3k plus 5. Okay, so 1 upon 3k plus 2. From here it will becomes k plus 1 and 3k plus 2 upon 2 3k plus 5. Okay, so 3k plus 2, this will cancel out. So what we will left with, that would be k plus 1 upon, it becomes 6k plus 10. Okay, so k plus 1, I can write it like 6k plus 6 plus 4. So from here k plus 1, I can take 6 as common, it will become x plus 1 plus 4, which is equal to our RHS. So since pk plus 1 is true, whenever pk is true, so by the PMI this result will be true for all n belongs to z integer. Okay, thank you.